Hello, and welcome to a Cloud Developer channel. In the last video, I showed you how to set up ultimate thread groups, which allow you to be able to set up a load test and be able to test how your application is behaving. In today's video, what I'm going to show you is how to take the information that's being generated by those tests and be able to start analyzing the information so you can actually see how your application is performing. So what we have here is a test that we set up in a few prior videos that I've recorded. And today what we're going to do is we're going to go ahead and run this test here and see the data that shows up in the result tree, which basically just shows us that the responses are working correctly. And then we'll add the capability to be able to actually graph that information. So let's run this real quick and see what the results look like. So in here, when I click on the view results tree, you see there's no data. If I start running it, you'll start seeing that we start getting information about the request and the response, and we can actually see it as the user would see it in the browser as well. So if I click on one of these, we'll actually see the page that's being displayed. So let's go ahead and stop this and clear the results. And so what we're going to do now is we're going to add a couple of additional options or configuration settings into this test so we can actually see the information. Now, one thing you'll learn about JMeter is it has the concept of these listeners, and these listeners are a way for JMeter to be able to record the information about your tests. So as you can see, I have a few of them installed here. By default, it comes installed with a lot of, or not a lot, but a handful of them that show you basic information. For example, the view results tree, which is what we were just looking at. There's a way to be able to see data in a table, and there's a handful of other ones that are installed. All these ones that start with JP at GC are custom plugins that were added. So what we can do is quickly take a look at the plugins that I have installed using the JMeter plugin manager. And what you'll see, and the plugins that we're going to be using today are going to be specifically these 3 basic graphs, 5 additional graphs, distribution percentile graphs, as well as KPI versus KPI graphs. When you actually click on these, it'll tell you the kind of graphs that are available here. But once you actually get them installed, you'll be able to just add and take a look at the ones that you're more interested in. So I've already gone ahead and installed these in my version of JMeter. So I'll go ahead and close this. And the easiest way to add them is by right-clicking, adding, and then going to listener, and then adding the different graphs that you want to have. So I'll give you a quick rundown of some of these that you can add here. So in fact, we can go ahead and just add all of them, and you can see the information that's actually coming back from them. So let me do that real quick, and then once that's set up, we'll actually walk through them after we run the test. Okay, so I've gone ahead and actually added all of these graphs that I'm interested in showing you today. And what we'll do real quick is actually go ahead and clear out the results, and then we'll run this test so we can actually get the information, and then you can actually see the kind of data that's being produced by all of them. So I'm going to go ahead and click this start button, and we'll give it about a minute and a half for the test to actually complete, and then I'll walk you through the different data information that's available in them and how you can use that. Okay, so as you can see, the actual test completed, and it took about a minute and 20 seconds to completely go from start to finish. We hit a maximum of 40 threads for this entire test, and then it executed in a stepped manner, meaning that it started at 5, and then waited for about 5 seconds and started going up to 10, waited a little bit, and then started ramping down, and all the way to 40 threads. And then it executed for a duration of time. So this was roughly about, let's see, so from 25 seconds to 55 seconds, so 30 seconds, and then it started ramping down, and then it finished. So as you can see in the view results tree, we see all the individual requests that were being issued. And if we go to the request tab, we should be able to click on it and actually see the data. And then these are each individual request that was issued. Now, that information is good when you're troubleshooting and you want to see the actual details of what each request actually did. However, what it doesn't allow you to do is it doesn't allow you to visualize the information to be able to start making decisions on how your application is performing. And that's why you want to add these other listeners so that you can actually start seeing the data. So we'll go to the first one, the active threads over time. And as you can see, that basically shows you a similar view to what you have when you configure this ultimate thread group. In this case, you can see the actual timing and configuration of how many threads and then when they're going to be added, how long each particular step in the process is actually going to be executing for, and so on. So you'll see that active threads over time, and then what you'll see is the time frame granularity is 500 milliseconds. So it'll actually be refreshing this view every 500 milliseconds, or show you in I guess time increments of 500 milliseconds. So you can see it basically happening live. So that's what this graph is useful for. Then when you go to bytes throughput over time, basically this shows you how many bytes per second you're actually dealing with and over a period of time. So in this particular case, this graph shows you granularity of 1 second. And you'll see that we've peaked at roughly, let's see, 10.2, I guess that would be kilobytes per second. So that's actually, well, it's 10,000 or 10 million bytes per second. So if I'm calculating it correctly, that's, let's see, so 10 million 24, and that's about 10 megabytes per second or so. So then we can go in and take a look at connect times over time. And in here, you really don't see a lot of information. And the reason for that is because this particular visualizer or listener actually shows you how long it took to actually establish a connection, not to actually execute the actual request, but is it actually connecting quickly enough? And because the granularity of the data is so small, you really can't see it because it's actually connecting really, really fast to the server. So I didn't find this particular listener very useful. And then hits per second, you'll actually see that we start ramping up, and as the thread count goes up, you'll actually see that the number of hits per second goes up as well. So we've actually peaked at roughly 4,400 hits per second, and as the time went on, we can actually see how many hits per second were being issued based on the amount of threads we actually had. And then if you go to response codes per second, you'll actually see there are two response codes in particular. There's 200, which is HTTP OK, which means that the request executed successfully. And then we also see another response code, which is 302, which was a redirect. And if you remember back at the creation of our test, you saw that our login page and our profile page would actually perform a redirect. That's why you're seeing the redirects. And you'll see that the majority of the requests were actually issued for 200s or response codes that were 200s, and then about 35 to maybe 40% of the actual requests were redirects. And then we can move on to the next one, which is response latency over time. And you'll see here for each type of a request that is being executed within our particular test, you can see each individual response time for that particular URL request. So you'll see that the response latency is in milliseconds, which is this left-hand side vertical. And then the horizontal is elapsed time. So as time goes on and the test is executing, we actually see a ramp up in the amount of threads. So you'll see that the latency for each one of these URL hits actually starts going up because the load on the server starts increasing. That's why you're seeing that. And then eventually the threads start going down and you'll see that the actual response times get better. So you can start taking a look and seeing where your application starts behaving very slowly and start looking at what you can do to increase the performance of that particular part of your application. And then a response time distribution, you'll see in this graph total number of responses that your application has been able to produce. And then you'll see where the majority of those responses actually land. So in this particular case, they landed within the first 100 milliseconds of all of our requests. And we see that a handful of the responses actually came in somewhere between 100 milliseconds and 200 milliseconds, and there's very few that came in between 200 and 300. So our application is performing pretty well considering the infrastructure that it's running on. And then we can move on to the response time over time. And then here, what you'll actually see is, again, you'll see response times in milliseconds. And this is kind of a different view of the prior graph that we saw. It just shows you a line graph. And then again, you'll see the type of URLs that were being tested, and then over time, how well they were actually performing. And as you can see, the login page is the one that takes the longest. So this is where we probably should spend more of our time, depending on the utilization of our application by our end users. And then response time percentiles. This is actually a very interesting graph to take a look at. Majority of the time you can take a look at this graph and see how well your application is performing by just simply looking for the 90th percentile distribution. So basically meaning that 90% of all of your requests are landing within this time frame, and then it's also broken down by the URL being tested. So you can see that the application started off with pretty quick response times in terms of value. So in here we were seeing roughly about 25 millisecond response times, and then as the application actually went up into 90% or 90% of our requests that were being issued, the response times were actually coming back within a 71 millisecond response time. So that's pretty good, again, for the infrastructure that we're on. So using this graph, you can do a very quick analysis of how well your application is performing if you start seeing any spikes, or how poorly the distribution of the actual responses are for each URL that you're issuing through this test. And then response time versus threads, you'll see that as the amount of threads actually increases, so which is this horizontal scale right here. So we see we had a total number of 40 threads, and the response times keep going up, and we saw a slight spike in this area here, which shows you around 26 threads. It actually spiked to 62 and then dropped down and started working better, and then eventually it goes up basically almost to the same point, so roughly around 59 or 58 in this case. So just another visualization of how many threads and what the actual response times are. And then you can also see transactions throughput versus threads. And what this will show you is the number of estimated transactions per second based on the amount of threads that are being issued. So you can start taking a look at where your application starts actually utilizing the majority of the resources on your infrastructure. So in this particular case, even though we saw a spike here and it started actually going down, you'll see that somewhere around about 26 threads or so is where our application actually started peaking at the number of transactions per second that it could perform. So this is kind of the sweet spot for our infrastructure and the deployment that we're doing. Keep in mind that we're running 5 Service Fabric VMs all on the same virtual host, as well as the actual machine we're testing from is actually on the same host. So we're actually basically loading it 100% up completely. If we had it actually distributed across multiple physical servers, then the throughput would be significantly different. And then one of the last graphs that I want to show you is this transaction per second. So again, it actually closely resembles some of our initial graphs that we saw, where you saw basically the stepping of the additional threads. So as we started having 5 threads, it actually started going up, then it waited for a few seconds, and then it started going up again. So what you're seeing here is the number of transactions per second, and this in this particular case is actually broken down by the URL as well. And then you'll see the granularity that is basically each second in terms of granularity. So this is just another way to see how many transactions per second for each URL that is being tested. And then actually the last graph here is kind of a summary report for the amount of samples that it was actually able to generate. So in this particular case, the number of transactions, and the total amount of transactions for this entire test was 103,587 samples, in average of about 17. And you'll see that's because our login page is actually is it the login page? Yeah, so the login page is actually taking quite a while. The rest of them are not taking as long, but the average then ends up being 17. So if our login page was actually faster, we probably see a better number here. So then you'll see the 90th percentile, the 95th percentile, 99th percentile, and then you'll see how many errors we actually received. In this case, we had no errors at all. The throughput, we had roughly 1,300 transactions per second, and then the amount of kilobytes received in this case, as well as sent. So you'll see all this data. You can actually save it in a table for later informational purposes. So if you want to actually record this somewhere. And then if you go to, again, view results, you can see all of this detail, specifically how many bytes were being sent, how many received. And you can basically start capturing this information in some kind of a Word document or some kind of a presentation so that you don't have to try to graph any of this in Excel. But if you wanted to, you can probably grab this aggregate report, or you can actually add some other listeners that actually allow you to break down all of the different requests in individual rows, and then you can deal with the data yourself. And it's as simple as just right-clicking, adding. You can add another listener, and in this particular case, you can do a view results in table. And then when you actually run this report here, you'll actually start seeing the request and response time information. Now, in this case, it's not actually summarized like it was in the other view, but this way you can actually export this information and actually store it and process it yourself. So hopefully this was useful, and you can start using it in your reporting for your applications. In the future video, I actually want to show you another capability that you can use. This is not part of JMeter, but actually leverages JMeter, and it's called Taurus. And this actually is an application written and maintained by BlazeMeter vendor, and they make it public for people to use. And what it allows you to do is actually automate some of the testing, and you can use it during your development cycle. This is actually a very handy application that you can use, and actually automates not just JMeter, but Selenium and other integration software for testing purposes. So I'll actually be doing a quick demo of how to use this for your development and optimization purposes in your application. So maybe we'll take a look at how to optimize the login process, or how to actually perform some basic caching for our session keys so that we don't have to actually issue a request to our Service Fabric application every time a different request comes in on a different node. So hopefully this was useful. If you have any questions, go ahead and leave your comments in the comment section below, and I will talk to you in the next video.